In Module 2, Lesson 19, we'll continue writing, evaluating, and finding equivalent expressions with rational numbers. Our first activity is a tic-tac review game to be done in the classroom. So rather than ruining that game, I'm going to skim past that. In example 2, we're going to complete the table by showing equivalent amounts. So our first column is the original price, or the 100% amount for an item. The second column would be the discount amount. That's how much is going to be taken off. Our third column will be the new price. And then finally, we'll write equivalent expressions, 3 equivalent expressions for each of those situations. So if our original price is $100, the discount amount would be 100 times 20%, which we'll change into a decimal of 21/100ths. And when we multiply that, we get 20. The new price, or the price that you would pay, would be 80%, because when you take 20% off of 100%, you get 80%. So that calculation would be 100 times 80/100ths, which is $80. And then finally, our expressions, we could do 100 minus 100 times 20/100ths, which is our discount. We can take our original price and subtract the discount amount, and that would give us the price. We could also do 100 times 1 minus 20/100ths, and that will give us the exact amount. Or we could do 100 times 80/100ths, which is the actual percentage that we're going to pay. Following that same pattern, the thing that will change with each row is the amount, or the original price, that we start with. So 50 times 20% would be a discount of $10. 50 times 80%, which is the new price, is $40. And rewriting the expression several different ways, we could do 50 minus 50 times 20%, or 20/100ths. We could do 50 minus 1 minus 20%. And we could do 50 times 80%. For 28, again, we're substituting, or we're changing the amount, or the price, or the original price. And we could do and 20% of 28 is $5.60. Then 28 times 80% would be $22.40. We could also find that by simply subtracting $5.60 from 28. And our expressions, 28 minus 28 times 20%, or 28 minus 1 minus 20%, or 28 times 80%. If the original price is $14.50, $14.50 times a discount is $2.90. If we wanted to then find the actual price in these situations, maybe simply subtracting the discount would be an easier option. And that would give us $11.60. So to show the rule, no matter what the price of the item is, and that's what X is representing, no matter what the price is, if we multiply X times the discount amount, we will get that discount times X. In this case, 20/100ths times X. And then we can represent what we did in the example right before this by saying X minus 20/100ths times X, and that will give us the price. And more simply, we're simply showing the different ways that we have been solving those problems. More simply, if we multiply 80/100ths times X, that would give us our price. So in looking at example 3, an item that has an original price of X dollars is discounted 33%. They ask us, first of all, to write an expression that represents the amount of the discount. So the amount of the discount, which is 33%, would be 33/100ths X, 33/100ths times X. Two equivalent expressions that represent that new discounted price could be X minus 33/100ths times X, or X times 1 minus 33/100ths of X, or 67/100ths times X. All three are equivalent expressions showing the same amount. They ask us then to use one of our expressions to calculate the new discounted price if the original price was $56. Although you don't have to do this problem a variety of different ways, the simplest way, in my opinion, would be 67/100ths times 56, which is $37.52. Question D, how would the expressions you created in parts A and B have to change if the item's price had increased by 33% instead of discounted 33%? So we're looking to see what we would have to change in the expressions if the item's price increases rather than decreases or discounted. So we look at A and B. We notice in A that this discount amount, that would not change. Because if it's increasing by 33%, we still need to know what 33% is. But in part B, when we talk about so if we're going to increase our price by 33%, this subtraction needs to change to addition. And the same thing would be true in the middle, and that's going to change our final percentage as well. So if we scroll down, we see that what we would be doing then is X, which is the original price, plus 33 hundredths times X. And just to show what that might look like, we could do X times 1 plus 33 hundredths, which would be 1 and 33 hundredths times X. So if you'll complete then the final table, or example 4, using the same guidelines and the problem set, you'll be able to practice the skill on your own. In summary, two expressions are equivalent if they yield or give you the same number for every substitution of numbers for the letters in each expression. The expression that allows us to find the cost of an item after the discount has been taken and the sales tax has been added is written by representing the discount price added to the discount price multiplied by the sales tax rate. So your sales tax is going to be multiplied by your discount price. And then you'll have to add the sales tax on to your discount price. Yes, it really is that complicated to go shopping.